Okay. Hello, everyone. Welcome to the Digital Cross Screen. And the TCP is organized by the 8 leading ICT company in the world. And actually, their headquarters, most of them are in Taiwan. Microsoft also joined us. And we have about 100 members. And however, they are the ICT supply chain. You know, ICT, they are a huge emission in the world. So everybody care about the new technology, especially the climate tech. So the carbon removal is what we concern. So it's our honor to invite some speaker, very important speaker, to join us. And what we want to know is the current scale of the carbon removal, the CDR. And the second is the scientific consensus and necessary for the CDR. The fund is enough, or what's the future? And the last one will be some because all over the world, including the US, they have the Carbon Dioxide CDR Research and Development Act, and also some historical approach and international cooperation. Then we want to know in these sessions. And so we have 3 speakers here, and 1 is here, and 2 online. The first speaker I would like to invite him to talk is Mark Briston Agonis, and he's a policy manager of the Bellona. And later on, I will invite into the Professor Lin Yongjun from the National Tsinghua University. He's a professor. And last, we will invite Matthias Honegger, and he is a senior consultant and Perspective Climate Group. So, Mark, the floor is yours, please. We'll go from here.
Great, thank you very much for the invitation. So a quick introduction to Bellona. We're an international climate NGO. We work in, we have an office in Oslo, 1 in Brussels, 1 in Berlin, 1 in Vilnius. I work in the Brussels office, working mostly on EU climate policy. And I'm going to give you a bit of an introduction to carbon dioxide removal. For some of you who've already seen a presentation from me, it's not going to be very new, but it's still very important to have the basics, because this is a conversation which is in many ways just starting, at least from a policy discussion. So I'm going to introduce some basic principles for us to have a further conversation on how to engage with removals in a policy sense. Let me see if this works. Yes. So firstly, why are we talking about carbon dioxide removal? Why do we need it? So the first reason is quite clear. Emission reductions are falling short. So here we have a very scary graph that shows the rate at which we could have cut emissions and remained below 1.5 degrees should we have started to cut emissions at that point. So from the year 2000, for example, we only needed a rate of 4% per year, but now that we've left it so late, this is in 2019, we need a rate of 18% per year, and this is without removals. Now we've obviously consumed more and more of the carbon budget, so the line gets steeper and steeper and steeper. Ultimately, the point is we have not done anywhere near enough to cut emissions, so we need to cut emissions. That's the fundamentally. Even if we maximize the amount of emissions that we're going to be cutting, not emitting, we still need to have to remove some CO2 from the atmosphere, and this is oops, sorry, I went backwards there. And this is because I'm going to skip this one. This is because carbon dioxide removal is an unavoidable component of net zero. So net zero, by definition, means that we're emitting something and removing an equivalent amount. Now, from the IPCC report that was published last year, the role of removals is quite clear. There's 3 sequential roles for removals. Firstly, before we reach net zero, as a way to accelerate emission reductions. So, not taking away from the need to substantially cut emissions. We need to massively cut emissions, and on top of that, any removals that we deploy must accelerate the reduction of net emissions, the amount of emissions that we emit that stay in the atmosphere. Secondly, at the point we want to reach net zero, there's 2 sort of net zeros that we're aiming for. Firstly, we're aiming for the balance between CO2 emissions and CO2 removals. So that's net zero CO2. and that's sometime around 2050 at a global level. And then there's a balance between residual greenhouse gas emissions, so non-CO2 as well, methane and NO2, for example, and then an equivalent volume of carbon dioxide removal for that as well. And that is then sort of GHG neutrality, sometimes called climate neutrality. And this is actually what the EU's 2050 climate target is. It's a climate neutrality target. All greenhouse gases must be counterbalanced by an equivalent amount of CO2 removal. And then after we've reached this sort of net zero point, then we are aiming for net negative emissions, where we effectively remove more CO2 from the atmosphere than we are emitting, or more greenhouse gases from the atmosphere than we are emitting. And we're able to reduce the amount of, we're able to reduce global temperatures down to more manageable levels, or I like to put it as less unmanageable levels. So what exactly is carbon dioxide removal? So now I'm going to give you a bit of an explanation of 3 different types of climate action. So we sometimes come across these terms. It's not necessarily clear how they're different from each other. CO2 avoidance comes up quite a lot. Now, this is generally measuring an assumption of an emission reduction, of a non-emission, effectively. So, for example, here we're seeing I have a coal plant, and I might make it bigger. Actually, no, I'm not going to. I decided I'm not going to make it bigger. So I've avoided emissions by not emitting more than I otherwise would have. So this is not a particularly ambitious type of climate action. It is necessary, but it's not quite as ambitious. Then we have CO2 reduction, and this is where we have a measurable change from the year before. So here, for example, I have a coal plant, and I don't know, I reduce the output. I reduce the amount of coal power I'm generating from it, or I install CCS on it. I managed to capture 90% of the emissions, whatever. The point is I've reduced the emissions compared to the previous year. And then finally, we have CO2 removal, where we're measuring a physical flow of CO2 from the atmosphere into permanent storage. And here what we're measuring isn't just the amount of CO2 that we've taken from the atmosphere and permanently stored, but also we're subtracting the emissions that were generated in doing that activity. And so if we look at this graph like this, basically what the atmosphere sees is this. So we remove the previous year, an emission avoidance, ultimately nothing has really changed other than it could have gone up worse. It could have gone worse. Here we've actually cut emissions, which is good, is what we should be aiming for. And at the same time, the last one is where we've actually removed from the atmosphere. And this is also what we should be aiming for, even though it's substantially harder to do that at the moment. Now, here are some definitions, some principles, which we can use to define when an activity might count as a carbon dioxide removal. Firstly, the CO2, let me just check. Yeah, so firstly, the CO2 has to be physically extracted from the atmosphere. So it cannot be captured from a point source that is only generating fossil CO2. That is, at best, an emission reduction, okay? So we're capturing from the air, or we're capturing via photosynthesis and with biomass and CCS. So the atmosphere, the CO2 originates from the atmosphere. That's the key point. Here are the 3 examples I mentioned. The extraction is done via the biomass for these 2 projects. Here it's done via chemicals, with the chemical process. Then the second principle is that the CO2 we extracted from the atmosphere, we're permanently storing it away. And here it's key that we use the word permanently. It is really the CO2 should never come back out. If the CO2 is re-emitted, then this was never really a removal. It was simply a delayed emission. And so we don't achieve the desired effect of reducing greenhouse gas concentrations. We just basically remove that greenhouse gas temporarily. We reduce the radiative forcing while that greenhouse gas is not in the atmosphere, but ultimately it goes back up and it stays there and accumulates, which is what we're trying to prevent. We're trying to reduce the accumulated level of CO2. So here the storage is in geology, and this is, we have quite a lot of evidence from the IPCC. There was an IPCC report in 2005 that suggests that the likelihood of CO2 coming back out after several thousand years is 0.000 multiple zeros, 1%. So it's very low risk that the CO2 is going to come out if you choose the site well, if you do the monitoring well, etc. Now here for the forestry example, the storage is also the biomass. So it's the capture mechanism and it's also the storage mechanism. The challenge is that generally the risk of reversal is much greater with biomass, simply because it's a shorter carbon cycle. It's more exposed to disturbances. There could be a forest fire, a drought, whatever. It's much more likely to come out again. it is theoretically something that can permanently store carbon, but it requires ongoing management. So even though CCS-based removals can be more expensive upfront, if we look at the long-term effect of having to continually manage a natural sink, it does become much more expensive. The third principle is what I was alluding to earlier. All of the emissions associated with this process of capturing from the atmosphere and permanently storing need to be included in the emission balance. And so here we can be talking of the emissions from power generation, from transport, any leakages that occur, etc. Those need to be accounted for and then subtracted from the gross removal that we've done. And then finally, and this is kind of, I guess, obvious, we need to be removing more CO2 from the atmosphere than we have emitted greenhouse gases so that we achieve a net removal. We achieve what we're actually aiming to do, which is we're reducing the amount of CO2 that was in the atmosphere before we did this project. Now, this is a IPCC graph. I won't go into it too much, but basically this is to suggest that there are plenty of different theoretical approaches to carbon dioxide removal. And the IPCC historically had gone towards a sort of technological versus nature versus sort of approach of splitting these approaches. However, they've foregone this and gone towards more looking at what is the process of the removal and what is the timeline of the storage. And that kind of gives us a bit more leeway in looking at how removals actually operate. But ultimately, what I want to show you here is there are only these geological formations and these minerals that store carbon for tens of thousands of years or longer, which is, for all intents and purposes, permanent. Now, when we look at marine sediment, this is centuries to millennia. This is also rather good. The challenge there tends to be more in the monitoring. But those are the timelines that we're talking about when we're talking about taking CO2 out of the atmosphere and making sure it doesn't come back out again. Now, these other approaches, buildings, vegetation, and soils and sediments, those, they list them as decades to centuries. I think for centuries, this is somewhat ambitious, but the point is, these are much shorter term, and the risk of reversal from these is much greater. So even though these could theoretically be considered as CDR, there is still a question of whether or not these are permanent ways of storing carbon. Now, ultimately, if we look at a CDR system, we need to be looking at the three main points: the source, the sink, and the system. Now, I won't take credit for this. This is from my former colleague, Samantha Tenza, who is no longer working at Bellona, but is now back in academia doing wonderful things. So ultimately, we need to look at where the CO2 came from, how is it extracted from the atmosphere, where and how is it permanently stored, and then everything that's happened in the system. What have we emitted? What have we potentially displaced? Those are important questions to look at. If we're building, for example, direct air capture in a place where there's dirty grids, there's very high carbon power generation, that's not likely to be a positive outcome. I'm going to skip through this. This is a visual way of representing the principles I've shown, looking at the first and second principle. So does it come from the atmosphere? Is it permanently stored? Now, this is a typical emission. So we take the carbon from the geosphere, we use it in an industrial installation, and we emit it. Here, we've added the extra step. We sometimes hear about capturing CO2 from an industrial installation and making fuels. That is still an emission. So there might be some kind of displacement effect, but that's very difficult to quantify. Ultimately, the point is the geological carbon that you've extracted ends up in the atmosphere. It accumulates in the atmosphere. We're trying to minimize and avoid that as much as possible. Emission reduction is when we take it from the geosphere, and then we use it in industrial installation, and then we don't actually emit it in the atmosphere. We put it back on the ground, and ultimately we haven't, in this theoretical example, which you're going to imagine is 100% capture, there is no emission in this, there's no CO2 that's emitted. In the final step, we're taking the CO2 from the atmosphere, and then through this chain, putting it in geological storage. We're, through this extended process, removing from the atmosphere and permanently storing. Now, the key point I want to make here is these two processes are never a removal, simply because the CO2 does not come from the atmosphere or is not permanently stored. It needs to be both of these principles together for the process to potentially be a removal system. Is that my time? Okay. I want to make an extra point, which is that storing carbon in circular products, so this is something that I alluded to earlier with, for example, buildings, is not permanent storage. And the difficulty here is, I'm just going to skip through all of this. Circularity is not a permanent store of carbon, simply because there's a lot of leaks in the system. So if you try to put biogenic carbon in, for example, paper cups, and then you have a growing stock of paper cups, you try to recycle these endlessly. In theory, that's, even in theory, I would say, it's very difficult to do this. There's going to be a lot of leaks. You're not going to collect all of the paper cups. You're going to put a lot of energy in recycling these paper cups. there's generally a lot of losses. So, and these losses will obviously compound. So after 3 cycles, if we have an 80% collection rate, we've lost half the carbon. And ultimately, we do 3 more cycles, we've lost another half. And then ultimately you end up in a system that's emitting more than it's actually removed. It's not worth it. It probably has some kind of climate benefit, not denying that, but it's not a removal. And I think that's really a key point to raise. We're often seeing a lot of things being lumped into the discussion of removals. These types of processes have a climate benefit, but they're not a removal. Now, what exactly does it mean if we want to reach net zero? This is a graph from a paper from Oxford, which basically shows the 3 different sort of carbon reservoirs that we have. So the geosphere, the land and ocean sphere, and the atmosphere. And ultimately what we're doing is we're dumping a lot of carbon in the atmosphere, and that's obviously not good. That's causing global warming. So if we want to aim for net zero at the moment, it's not really clear where that carbon needs to be stored. So a lot of assumptions are that we're just going to be able to emit CO2 from the geosphere, dump it in the atmosphere, and then we're going to somehow be able to store it in the land sphere, land and ocean sinks. That's not really a sustainable solution because what I mentioned earlier, these are not particularly permanent sinks. They're very likely to reverse in the long term. And we might also go beyond what those carbon reservoirs can actually sustainably store. So this is not what we should be aiming for when we talk about net zero. Ultimately, what we need to be doing is finding a better way of balancing between these different carbon sinks, carbon reservoirs, to make sure that if we're emitting any carbon from the geosphere, it goes back into the geosphere. And we're basically sort of restoring the geosphere, if we can call it that. The point being, we can't rely simply on the land and ocean sinks to sort us out because they are not permanent sinks. They are very likely to reverse, and we're pushing the planet beyond what it can sustainably store. So there are 4 key sort of recommendations that we provide when it comes to that we give to policymakers when it comes to carbon dioxide removal. Firstly, is that we need to establish ambitious emission reduction targets. That's policy recommendation number 0, 1, 2, 3, and 5. Number 2 is that any removal target needs to be additional and separate from these targets for emission reductions to make sure that we don't dilute efforts to cut emissions, which remain the lion's share of the effort and I guess easier to do. Third point is that we need to manage the land and geological sinks separately for the reasons I mentioned earlier. The geosphere tends to be significantly more permanent than the land sinks. And not saying there's no benefits to storing carbon in the land sink, but it requires separate management frameworks. And finally, we need to regulate and clarify what net zero actually means, because it doesn't make sense to allow a fossil fuel company, for example, to emit a lot of CO2 into the atmosphere and to then store that in the biosphere, where it's just going to come out again in 10 or 15 years. We can't let companies just buy mangroves and pretend like they're carbon neutral. That doesn't work. They need to put the carbon back into the geosphere. I can also give a very quick introduction to the carbon removal certification framework at the EU level, which I've been working on. Now, basically, this is a legislation that was proposed late last year, and it establishes a basic legal framework to develop quantification methodologies for different types of removal activities. It establishes some definitions and basically gives the Commission the power to develop these methodologies. It's not yet a finalized piece of legislation. They're currently going into what's called trilateral negotiations. So the Council, the European Parliament, and the European Commission are currently negotiating what the outcome of this should be. And broadly speaking, these are it aims to identify and quantify where the carbon is coming from and going, how much is being removed, what's the net removal. The understanding is that this could lay the groundwork for inclusion of removals in the EU's broader climate policy. But the point is, without the ability to quantify these things, it's going to be very difficult to do so. So this is basically a way to make sure that we understand what we're doing when we deploy a carbon dioxide removal sort of process, that we're able to quantify it, and then we can better understand where it fits in EU climate policy. It should really have set some basic definitions and principles, but the way they've defined it isn't particularly clear. This has since changed a little bit, but the definition of carbon dioxide removal at one point included emission reductions, which is very misleading, and it goes against the principles I showed you at the beginning. The way they define permanence, one of the institutions has gone has gone the right way, has really pushed to make sure that we at least use geological storage as a benchmark, whereas the other has not, and has kind of chosen a rather vague way of defining permanent storage. The liability, if there's a reversal, again, one of the institutions has gone for rather clear guidelines that if it comes out, then someone should be responsible for paying the ETS price, for example, whereas another institution has not. And it's not particularly clear in how the different types of removals that are in this piece of legislation will be managed. So they have three separate buckets. One is carbon storage and products. One is carbon farming, which is basically land activities. And one which is permanent carbon storage, industrial carbon removals, they call them. But how these are distinguished is not very clear. So obviously, during these negotiations, we will be pushing to make sure that the definitions are clear, the liabilities are clear, that permanence is well defined, and that there's a clear distinction between these different types of activities. And there's still a lot of open questions beyond that, such as what are these certificates ultimately going to be used for? Will they be sort of getting in the way of emission reductions? Will they be undercutting efforts to cut emissions? And how will these different characteristics of removals be taken into account? And that concludes my presentation. Thank you very much. Please get in touch if you have any questions.
Thank you, Mark. I have a short question. What about how much is, how much the volume we had already used the CDR now?
How many?
Yeah, how many tons right now?
Very little. I mean,
very little.
Relatively, very little. So I think at the moment, the state of CDR report, which was published earlier this year, I think, or maybe late last year, estimated about, I think, 2 million tons of novel CDR, they call, which is basically BECCS and DACS and some early other approaches. But very, very small volumes of CDR at the moment.
So is a problem of the scientific problem or certification problem?
I think that the challenge is that the process of capturing CO2 from the atmosphere and then permanently storing it away is very expensive. It is very difficult with reason. I mean, physically what you are trying to do is reverse what we are doing at the moment almost by accident. We're using fossil fuel energy and it releases CO2 as a byproduct, as a side effect of us generating energy. And here what we're trying to do is pour energy into reversing that process. So obviously that's going to be much more difficult. And this is, again, why we keep pushing on the fact that even though we do need removals, it's very clear we need removals, it will necessarily have to play a small role overall, simply because it is more difficult than just not emitting in the first place.
So technicals, certifications, and commercialize. So how many years we will take to reach that?
I mean, that's difficult. At the moment, so for a long time, this has been a largely academic discussion and very theoretical. And now we're starting to see real projects come up. And in having these real projects come up, we're sometimes coming across very real technical challenges. So for example, the Climeworks project in Iceland, they had a small project that was removing 4,000 tons per year. It was, it's tiny volumes, but it is the first of its kind, and it's a pilot project, so it's normal to have these very low volumes. And in moving towards the bigger project, which is almost 10 times larger, they've encountered some engineering challenges, which they weren't aware of. And this is what we kind of need to be doing. Between now and sort of 2030, we need to be deploying these projects in a controlled manner, in a bit of a sort of sandbox, to make sure that we can actually understand how they work, how we can quantify them, what the challenges are in deploying them, those kinds of sort of issues that you'll only really encounter once you actually start building these things. But at the same time, we need to make sure that these don't sort of undermine the broader climate policy architecture that we have. And at the moment, we're seeing a bit of a discussion where before we've really done that part of the development, we're already talking about policy change. We don't actually understand necessarily how these things fundamentally work, but how they work in practice. So there's a bit of a tension here between basically trying to put the cart before the horse. And we need to be a bit more careful in understanding that this is going to be a slow process because we still don't have tools to quantify. We still have these sort of policy mechanisms that I was talking about. So, it's a big challenge to make sure that these projects can kick off without, causing disruption within the broader climate policy sort of ecosystem.
Okay, thank you. Maybe later on we have a panel discussion. And right now I will give the floor to the Professor Lin Yongjun from the Tsinghua University. Professor, the floor is yours, please.
Okay, thank you, Chair. Can you see my screen?
You hear me? I cannot
yes.
hear your voice. Please talk, speak.
Can you hear me?
Yeah, I cannot hear you.
Just a second.
Professor, I cannot. Professor Lin, I cannot hear you.
Okay, how about now?
No, no, no. It's okay.
The problem is in
hello,
the room.
hello?
I can hear you.
Okay, right now it's okay. Yeah, please.
Hello, hello? Can you hear me now?
Yes, okay, wonderful.
Okay,
Please.
thank you. Thank you for having me. I'm an assistant professor at National Tsinghua University in Taiwan. My research focuses on developing solvent-based CO2 capture technologies. I have experiences in working on US DOE pilot plant project when I was doing my PhD, and I have 3-year commercial experience at Mitsubishi Heavy Industries developing the second generation of CO2 capture technology before coming back to academia. So Mitsubishi Heavy Industries is one of the major technology licensor for CO2 capture. I would use CO2 capture as the word because I see Mark define CO2 removal as the negative emission, but I see CO2 capture as in a broad sense because technically they are very similar technologies. So today I want to share how CO2 capture can contribute to achieving net zero emission in Taiwan. So this is the roadmap that proposed by Taiwanese government last year about how to achieve the net zero emission target. I have the current emission portfolio on the left-hand side and how much we plan to reduce by 2030 and 2050. So if we look at the non-electricity emission, industrial emission contribute the most in non-electricity section, accounting for almost 30%. And most of it coming from steel making industry in Taiwan, cement production, and steam use for petrochemical industries. They are the major emission sources in the non-electricity section. And the electricity emission account for over 50% of total emission, and that mainly because we still burn a lot of fossil fuels to generate electricity. Over 80% of electricity is generated from natural gas and coal-fired power plant. So if you want to reduce the CO2 emission, the target that proposed by the government is 24% by 2030 and 100% by 2050 to achieve net zero emission. If we look at how we plan to achieve that, for the non-electricity part, the government proposed to use new fuel, including hydrogen and biomass, also CCS, carbon capture and storage, and also electrification, for example, electric vehicle. And in the electricity section, the renewable energy is supposed to increase to 60 to 70% in the power generation. I think we're less than 10% now. So that's a very aggressive development. We need a very aggressive development for renewable energies. There will be 10% of hydrogen, and also natural gas plus CCUS, that will be 20 to 30%. We still have some non-reducible emission, and that has to be offset by the negative emission that already mentioned by Mark. That could be biomass or CCUS. So that will be the direct air capture, for example. So that's the roadmap proposed by the government. And here I want to emphasize that CO2 capture or CO2 removal plays a very important role in every section in this roadmap and is necessary to achieve the goal. So for example, CCS can apply to steel making industry, cement industry, and even blue hydrogen production. CCS can help decarbonize power plant by reducing the CO2 emission from the gas power plant or coal-fired power plant. And it can be used as a negative emission method to capture CO2 direct from air or from the biomass flue gas. That is regarded as the negative emission as well. So we know high CO2 capture cost is still the major challenges. And thermodynamically, how much work is needed to separate and compress CO2 as function is important variable. Because that determines how much cost of every ton of CO2 being captured. So in the electricity emission, we expect that reduce 11 to 15% of total emission. The CO2 partial pressure is 15 kPa from coal-fired power plant and 4 kPa from natural gas combined cycle. There are some activities in Taiwan here. We don't have any commercial plant yet, but we have some small pilot plant activity. The state-owned power company, Taiwan Power Company, they are building a a small pilot demonstration plant. They want to test for coal-fired flue gas. For the industry emission, there are several emission sources. If it is fossil fuel burn a boiler, the CO2 partial pressure will be similar to the flue gas and also cement. For steel making, we have relatively higher CO2 partial pressure from the blast furnace. And also, if this is for hydrogen production, the CO2 partial pressure can be as high as 200 kPa from the shifted syngas. So that means that will be easier to be captured. The cement company, the steel company, and also the petrochemical companies, they all have some activity on the small pilot plant demonstration. But again, we don't have the plan for large pilot scale plant and also commercial plant yet. For the negative emission to offset the non-reducible emission, the target is to use direct air capture, but that will be difficult because we have to recover the CO2 from the air, which is 400 ppm. The CO2 partial pressure is much lower than the point sources. And also the above mentioned companies, they are testing the microalgae biofixation as well. And they think this is one of the solutions for negative emission in the future. So we know high CO2 capture causes the major challenge. So here shows thermodynamically how much work is needed to separate and compress CO2 as a function of CO2 partial pressure. So what I'm showing is the minimum work in kilojoules per mole CO2. That means how much work you have to put in, how much cost you have to put in as a function of CO2 partial pressure at the inlet. And the CO2 capture technology was typically used for natural gas treating, so that's the high pressure range. But now what we want to apply to is in this range. So as here we can see the work required increases exponentially as the CO2 partial pressure decreases. So you're going to spend more and more energy from blast furnace gas, from coal fire, from natural gas, and all the way to direct air capture. And that's the reason why this is difficult, simply because the CO2 concentration is just too low. So economically, we should remove the CO2 from the concentrated source first, because that's more economically. And it wouldn't make any sense to do CO2 capture while we're still emitting concentrated CO2. So I don't think that's a choice of one or the other. That's what we should do different things at different stages. So to look at the challenges in Taiwan here, I think we need more aggressive regulation policies. The Taiwanese government proposed that CO2 carbon emission penalty should be start from 2025 at a rate of $10 per ton. I think that's definitely too low and too weak to actually to be effective. And I think we should use the carbon trading system similar to the EU system to actually guarantee the carbon emission. Otherwise, some companies might simply just pay the tax and get away with it. And we need more incentives to boost the technology development, similar to the 45Q in US. We need long-term CO2 removal strategies. I think we should electrify everything while decarbonizing the electricity. If you want to do carbon management, we should centralize it to get to let it be more cost effective. And I think we should remove the CO2 from the concentrated source first, and then dilute sources. There's still a debate if we need to do CCS anyway, should we do with gas or coal, because it's more difficult to do with gas. And we should think about where the captured CO2 should go. Should be to storage or utilization. because CO2 is a very stable compound, so it's very difficult to convert CO2 to another product and reuse. That might actually cost more energy and cost. So permanent storage might be a better solution considering the carbon cycle. Finally, the needs for CO2 removal technology development, I think the government should be the lead. They should fund a large-scale demonstration project, just like the DOE funded the Petro-Nova project in the US, the Boundary Dam project in Canada. The government should also fund the shared testing facility for the companies, for the university to develop the technology, just like the National Carbon Capture Center in the US, the Technology Center Mongstad in Norway, so we can do the research, do the testing with less cost. We should do the integrated capture, transportation, and storage demonstration project to finalize, to actually demonstrate the whole supply chain. And also infrastructure for CO2 transportation is also important to connect different sources and the sinks. So this is my share today, and thank you. I would be happy to have discussion later.
Yeah, thank you, Professor Lin. My questions continue the same questions. Right now is only the pilot study research only in Taiwan now, or
Right.
what's the volume right now?
Well, so the typical small pilot tent test is several tons per day. So that's very small scale. And we typically define several tons per day. CO2 capture is small scale. And if you have 100 tons per day, that would be large scale. That would be 1,000 tons per day. That would be commercial scale. So we are still in several tons per day scale right now.
Yeah, probably later on we can discuss about how far is it from right now from the pilot and also side research to the commercialize to solve the problem. Okay, right now I will give the floor to Matthews, and he had prepared a presentation, and actually he's online now right now, and he still prepare a very wonderful video. Okay, please.
Good afternoon. Apologies for coming in remotely, but I look forward to give you a quick presentation on carbon dioxide removals in climate policy by way of this recorded message. I will try my best to join the discussion on stream live afterwards. So let's jump right in. Carbon dioxide removal, where does it fit in the picture of international climate governance and climate policy at the national level? It's not evident, at least not to everyone, that carbon dioxide removal is really one of two types of climate change mitigation. And that is, if we really carefully read the language, the text that is both in the UNFCCC, the text from 1992, and in the Paris Agreement text from 2015. Mitigation, as you can see here, is one of many puzzle pieces in international climate governance. But all of those pieces are interlinked in sometimes evident and sometimes less clear manners. We will go through a little bit how those interlinkages play out and how a better understanding of what removals are based on their definition, how they can be differentiated from emissions reductions, how that's all relevant to the discussion that we have when it comes to implementing these approaches. So, like I said, there are two approaches to mitigation. Emissions reductions are what we have been talking about most of the time when it came to mitigation overall. And many people still use emissions reductions as synonymous with mitigation of climate change. But I want to be very clear that all the provisions in the Paris Agreement and in the UNFCCC texts that speak of the mitigation of climate change also pertain to and include CO2 removal or carbon dioxide removals and removal of the other greenhouse gases that are under the mandate of the UNFCCC. And what does it mean to do a CO2 removal or to achieve a result that is a CO2 removal? It means that the ton of CO2 or the molecule of CO2 is taken from the atmosphere and put into durable storage away from the atmosphere. Of course, there are debates what durable means, but let's just take that at face value for now. the background of the recent emergence of this topic is, of course, the International Intergovernmental Panel on Climate Change's assessment that speaks very clearly about the need for carbon dioxide removal or the removal of other greenhouse gases to meet, for example, a net zero milestone sometime in the second half of the century or by mid-century, depending on, well, also the geographical scope, whether we talk about a global scope or about individual national pledges. And this is somewhat confusing when you look at this graph because, you know, normally we only look at the net emissions level, and that's the curve from the top that goes downward to the right, with the blue line ultimately showing the gross emissions. But actually, what's interesting is not just the difference between gross emissions and net emissions. So net emissions being the line that goes down to cross the zero, roughly 2/3 of this figure. But also the yellow and or orange graph parts of the graph under the zero line. And that represents essentially the scale of removals. And you can already see, oh, interesting, we're already seeing significant removals. But, and this is an interesting challenge, there has been just a paper published in Nature a few days ago that looks at this. This is, of course, removal on land, on forest, on managed forest land primarily, which is being considered for the purposes of the accounting here as a anthropogenic removal, and so contributes to reaching this net zero point. However, much of this is basically debatable to which extent that removal is even man-made, human-made. It's basically a natural process that is happening while the area of land is under human influence. But whether or not there is a direct causality between the removal achieved is an open question. And in many cases, it might not be so clear. However, what's furthermore important to see in this graph is the light orange area. And you can see it's basically imperceptible early on. So at the line of 2010, of course, that's already in the past. It's essentially not visible, and it only starts to become visible later in the later decades of this century, though it already starts to grow. If you were to zoom in, we would see that already today. So this is here bluntly called other removals, and so this is an umbrella category for all sorts of approaches, including, for example, combinations of bioenergy utilization with carbon capture and storage, whereby the biomass representing a sort of climate neutral source of carbon, if it is being stored, it actually achieves a net overall removal from the atmosphere because, of course, the biomass itself had taken CO2 as the plants grew, had taken CO2 and embodied that CO2. And when you transform that biomass by burning it or otherwise transforming it, and you capture the CO2 from that and store it permanently, then you have overall a net negative emissions flow. And there are other approaches you might have heard of, such as direct air capture with geological storage, DAX, or enhanced weathering, application of biochar, and a few others that are being considered, but that yet aren't really perceptible in terms of their contribution. Now, this is another look at this, and you can see here the differentiation being made into BECCS as a broad category, biochar, and other quote-unquote novel CDR approaches. Biochar is, of course, a curious one because it's in no ways really a novel approach. Biochar has been used in agricultural production for centuries at the very minimum. So it is only a novel approach insofar that it is now being considered to contribute more substantially to carbon dioxide removal and thus to mitigation of climate change. So how mature is BECCS? Well, there are plans that are already operational. Now, certainly you may have heard of DRAX, it also in context of some controversy. DRAX is essentially a transformed coal power plant that is now running on biomass. It has been in the media for actually using biomass, in part also from the US, for limited biomass supply in the UK itself. And as such, is of course, has been questioned whether that is a sustainable practice. I don't know the details about that, but I can tell you that this is just one of many possible applications. Concretely, what I have been hearing and seeing also, for example, in Switzerland, but also in Sweden, is really this equipping of an existing biomass processing facility using biomass that is already in use and equipping that with CCS capability. So really doing nothing to the bioeconomy and leaving that untouched. Stockholm Exergi is a plant in Sweden which produces both heat and district heating based off of, in my understanding, really quite sustainable amounts of biomass. But of course, the devil always lies in the detail. And there have been in the past quite strong debates around the ethics and the governance of removals overall. And that is, of course, still at a very aggregate level, but in some cases, we can learn from that aggregate discussion also when it comes to setting more specific guardrails for doing these kinds of activities. And I wrote with colleagues a paper a year ago on governance principles for carbon dioxide removal. And what it tried to do is really situate this topic of CDR in the broader landscape of environmental and climate governance, as well as other international norms, in order to give structure to those debates and help make them perhaps more productive. So this means to situate CDR within the context of raising mitigation ambition, the context of and the need for international support and cooperation, the need for environmental integrity through correct measuring, reporting, and verifying of the results, for example. It is also in the context of equity and sharing fairly the efforts that we need to do at a global stage, but also within countries. Recognizing also that these decisions on climate policy implementation are at the national level and thus need to be nationally appropriate. The need for public deliberation and participation as appropriate, especially when it comes to decisions at the local level for new infrastructures and installations, but also, of course, to the bigger role of various approaches to achieving mitigation targets and what those targets should be. Sustainable Development Goals, the 17 goals, set a very broad range of normative endeavors and visions to pursue, to which carbon dioxide removal should be contributing. A duty to prevent transboundary harm, which is in particular relevant for the open systems approaches that I didn't really talk much about, but you know, there's quite a bit of growing attention on ocean-based CDR. A need to keep the long-term needs in mind, and so to prepare also for the future situation, for example, of having to reach net zero, so not just reap the low-hanging fruits, but also do that, of course, for quick action, but also then prepare for the long-term needs. And take action so that there is no over-promising, but also no under-delivery. So to follow promise, pledges with real action, and to expose, you know, from a country point of view, formulate pledges and targets in such a manner that they can be scrutinized, expose that to the public by specific targets that one can pick apart and understand whether or not a country is on track. That is an absolutely essential component of making sure that we stay the course. Baseline and credit carbon markets are a potential tool to accelerate transparency. Consistent MRV approaches are important for this. I won't go further into detail, but you might know that this COP is hopefully overseeing the adoption of comprehensive rules, both for methodologies in general, but also for the removals in particular. So the key points are CDR is a form of mitigation. The science says it is absolutely essential that we move and move fast on CDR. CDR is a very heterogeneous and complex ensemble of approaches. BECS may be more than what it might seem at first glance. Carbon markets can offer MRV approaches. There is a need for a reliable funding outlook that is aligned with the investment horizons. I didn't get too much into that, but I think it's evident. And with that, I thank you for your attention and look forward to the discussion.
Okay, thank you, Matthew. Mark, have a seat. Right now, we'll go to the panel discussion, and two of them are already online. And actually, my background, I'm a Secretary General of TCP, and we set up about 3 years ago. In the very early beginning, we think carbon removal is the best choice we can do. And so I have actually two questions, but I linked together to ask three of you. Maybe Mark will be the first, because what we found, the carbon removal is just only the technical science-based issue. How far is it? And to be commercialized, just we buy the carbon to forest, to plant a forest or something to get a carbon credit. How far is it to that stage? And the second is such as kind of enterprise, is ICT enterprise, what they can do. To be in the future, if you have a such as kind of an ecosystem to just like a link with the carbon credit, to buy it, or to invest it, because right now lots of the enterprise they already invest the solar PV, offshore wind farms. Some of them already have this, and but the carbon removal market is not so clear. So my question to all of you, and later on I will leave some question to the audience. Please, Mark, please.
Thank you. I think the first point is, well, it goes back to what I said earlier about what can all of these companies do. And the first answer to that question, until we sort it out, will always be minimize their own emissions. So what can they do to minimize the emissions that they generate and the emissions that they are responsible for? And only once we've really gotten down to the bottom part of that, the residual emissions effectively, should they start to rely on removals. Now, we talk a lot about carbon credits, and I think that discussion is a bit fraught. We've seen the voluntary carbon market go in directions which suggest that it's not a particularly sustainable way of engaging in climate action. So ultimately, if a company like these tech companies, if they want to spend money, if they want to invest, if they want to buy something to not just look good, but to actually sort out the climate crisis, removal is not necessarily the way to go about that.
Okay.
So there's a lot that still needs to be done on, for example, you mentioned solar. I'm sure they're investing on solar for their own use, but maybe there's something they could be doing in solar for others. Not saying that those should necessarily generate a credit that they can then sort of use as a claim, but they should be spending more money on climate action more generally. There's a big discussion at the moment with regards to whether or not we should be allowing compensation claims versus what's called contribution claims. So a company can spend money, and instead of trying to seek out the greatest amount of credits so that they can then make a net zero claim, that they can spend money and try to generate the greatest climate impact that they can with that amount of money. And then they can say, we spent X amount of money trying to minimize the climate crisis. That, to me, seems a more transparent way of spending money. It avoids a lot of the discussions around greenwashing. And it also enables that money to be spent in perhaps more creative ways that are perhaps more important than trying to get 1 ton of credits. Say, if we invest money in grids, for example, then we're not necessarily able to generate a ton of credits, but the impact of having that grid is probably much greater than that. So we need to be a bit more creative in the way that we think about how companies should be spending their money to and not just look good on climate, but to actually achieve an outcome on climate.
So right now the capital market is mature enough, just like we invest solar PV, right? Is mature enough to do that, right?
I don't know. I mean, I'm not really well placed to comment on the solar market. But at least from a sort of a carbon accounting perspective, a company that emits X amount of CO2 and then chooses to buy X amount of removals to counterbalance, or just credits or whatever, it's not necessarily going to all add up in the system, because we need to achieve net zero at a system level, not just at a whole bunch. It is obviously a whole bunch of individual net zeros that add up to a global net zero, but that needs to be sort of done in a coordinated manner. And if you allow individual entities to kind of individually assign themselves the ability to choose to claim net zero, then there's a big risk that it won't actually all add up.
Okay, thank you. I'll give the floor to Matthew, please.
Yes, thank you. I hope you can hear me well. So one of the things that I touched on in the presentation is this need to keep the long-term needs in view also. And so this is perhaps to slightly contradict, but perhaps just add to what Mark just said. I think, making sure that everything adds up today is one thing, but actually if we manage, if there's a will in the private sector to fund some of these extremely, at the moment, very high cost CDR approaches that, in contrast to land-based mitigation approaches, might have a much more credible outlook for permanence and actually achieving removals. I think that is a good thing. So that isn't a statement whether or not one should do that through compensation claims. I'm a bit more agnostic on that question, but I do think that there is an important avenue here to open up. And if the choice is between afforestation removals versus someone willing to pay several $100 for a inherently permanent CDR result, I would go with the latter, because that is, in my mind, at least when you look at the financials, a clear demonstration of a willingness to advance things quite rapidly at this point. And I mean, the question started off about where we are at in terms of commercialization and opportunities. I think that's where now is going to be a lot of movement in the markets. We've had, these early movers, Stripe, Microsoft, etc., with their advanced market purchase agreements, and they're still out there looking for high quality projects. So that is still a big opportunity for early development stages. It will be interesting to see what happens when the volumes actually increase, whether or not those buyers and additional buyers hopefully coming in would sort of keep up with additional offers on the market. So that's something I think we need to watch out for over the coming few years. That's going to be very dynamic because, of course, the starting point is still extremely small when it comes to some of these technological removals. So I think the market dynamics we have yet to see, but I do hope that also with the increased scrutiny in voluntary carbon markets flowing from some of the more challenging land-based or forestry-based credits, I think that scrutiny might be actually a force for good in driving more buyers towards some of the higher cost, at least at the moment, types of approaches that might have a greater, chances of really demonstrating clearly CDR results. And so I do hope that this opportunity actually manifests, and I'm rather positive, actually.
Yeah, I'm wondering the funding from the government, international cooperation is not enough, is very far behind with your respect. perspective, I'm wondering is very far behind the Rio, right?
Is that to me or sorry?
Yeah, up to you. Yeah.
Sure. Okay. Yes, absolutely. I 100% agree with that statement. And that said, I do think that we are in a phase of transformation when it comes to first having to set out to demonstrate the quote unquote MRV infrastructure, and in demonstrating that some of these approaches that haven't been done in the past are feasible and they work technologically, they work to demonstrate results. And so sometimes governments need to see those early steps play out before they actually move in and actually support efforts. I think in the current landscape, the US is perhaps the exception in this. Some other countries are close to following, perhaps in some ways, the lead of the US. But indeed, I mean, this is something that needs to broaden out, and we do need to see much more government commitment, indeed.
Okay, I will give the floor to the Professor Lin. Yeah, please.
Yeah, so the first question I would say it's already technically feasible, but still not economically feasible. I'm sorry, I mixed CO2 reduction with CO2 removal together because they are essentially very similar technologies. I'll use the example, the only two commercial plant or coal-fired power plant right now. One is in US, which is the Petra Nova project in Houston. The other is the Boundary Dam project in Canada. The cost right now to remove CO2 from coal power plant is $60 per ton. And they use the CO2 for enhanced oil recovery. They got a lot of funding from DOE, and they got additional credit from US government as well. But still, it's not enough to pay off their cost. Well, I believe they should have positive profit, but there's always, if you want to capture CO2, you really need enough incentives, or the regulation, the policy regulation should play an important role to drive the whole technology to move forward. Or otherwise, no company will initiate these CO2 capture technology. So I think for the whole world, for Taiwan, I think the government plays a very important role, and for two purposes. One is to drive the technology to move forward. The other to have an actual regulation. So this is my point of view. So I would say the funding opportunity in Taiwan is enough, and it's very far behind if you compare to other countries, from Norway to US. That is just very, very far behind. And in terms of CO2 removal from the air, there are many companies already demonstrate it's possible, it's feasible. For example, Climeworks and Carbon Engineering, they already have some pilot plant demonstration, and it works. But still, the problem is they estimate the cost is $600 per ton of CO2. Totally makes sense, because you want to recover CO2 from that dilute sources. It's going to be how much it's going to cost. So yeah, the key, I just want to emphasize, is technically feasible, but not economically feasible yet. And it should be driven by the policy. Thank you.
Yeah, what about linkage between your side and to the global? For example, the Mark and the Matthews. What's the linkage from Taiwan society, your science base, and with international? Because I found Mark and Matthews, you have very strong link with the UFCCC, the certification in the future, right? So for our local side, we should follow such kind of procedure. Yeah, Professor Lin?
Yeah, I think we definitely should do that. So I think one thing, so I'm working with the steel company in Taiwan now, even though we don't have any regulation yet, but they are very active in want to develop this technology. And the only reason is that they sell their steel to the Europe, and EU now they are going to have the broad tax policy, so they will be affected even though we don't have any regulation yet. So we are effective passively, and I think we should do something connect to the world by our initiatively as well. So I totally agree with that.
Okay, thank you, Professor Lin. I will
Yeah.
open the question to the audience. Anyone have questions or comment?
Hi, I'm Dorothy from World Trade, the Taiwanese World Chamber of Commerce. I just would like to share with you actually that even Professor Lin didn't mention about that the first CDR project, I mean, from biochart is going to be realized from February of next year. Actually, the machine has been ordered, but it's for biochart. So it's not something related to carbon capture storage in Taiwan that Professor Lin has been mentioned. But I'm very interested about what is going to be happened for the certification process for biochart, actually, because it's really different from what I've done before over the past 20 years about emission reductions. So, actually, to my knowledge, then to my research now, that certification company or even certification from the laboratory are very, very different, and it costs a lot. So, what you guys, Matthew, and also our ground that you're going to recommend us what to do?
Please, Mark.
I'll start. Would you want to?
Sure.
Okay.
Go ahead, Dave.
So on biochar, as you say, it's not the same process as with CCS, as with biogenic CCS or direct air capture with CCS. It's the only similarity really is that the extraction from the atmosphere is the same. Then the storage medium is obviously very different. At the moment at the EU level, the discussion on where biochar sort of fits within the framework is unclear. So our position on this is that at the moment, the evidence that we've seen does not suggest that biochar is as permanent a carbon store as geological storage is, or as the mineralization of CO2 might be. There is a growing body of evidence that is pointing in that direction, but from what we've seen, those studies have been mostly lab test results. And there's, for some reason, an aversion in the biochar industry to open up this discussion towards real life deployment and real life sort of lab, real life tests, sort of field tests. This is an issue that we've raised a few times. We had this discussion within the European Commission's expert group on carbon removals. And this is in stark contradiction with other approaches like enhanced rock weathering, where they are very much following that route of doing field tests and trying to really determine the risk of reversal via enhanced rock weathering, what the monitoring difficulties might be. There seems to be, within the biochar discussion, a bit more of a trying to jump into the permanent, sort of very much claiming that it is a permanent carbon store without necessarily doing the homework to really prove that it is. And it's not to say that it might not be, but the point is that there is still a few sort of steps that need to be done for us to be confident as environmental organizations to endorse a technology which at the moment does not have the sort of scientific backing to generate a carbon credit that one is going to be purchasing to counterbalance an emission of CO2 that will stay in the atmosphere for several centuries, several thousand years. So biochar is an interesting one because it does have some potential, not just as a carbon removal. So if we apply it in agricultural fields, there are quite a lot of studies that suggest that it's good for agricultural yields, it's good for water retention. So I think that in the meantime, whilst we are discussing the potential for biochar as a removal, we shouldn't sort of keep our eyes off the ball and try to see the many different applications of biochar that could make sense, and almost thinking of carbon dioxide removal as a co-benefit. So we're seeing a lot of focus of just trying to do removals almost for the sake of removals. And that's almost why we've also seen a large focus on direct air capture. But ultimately, direct air capture is an energy sink. It's really, you're just using a lot of energy to suck CO2 out of the atmosphere and print a carbon credit that someone can buy. And ultimately, there is a climate benefit to doing that, but we're wasting a lot of energy in doing that. knowing that that energy could have been used in other ways and could have been used in ways that could have potentially reduced emissions by more, could have generated a greater societal benefit than simply printing a piece of paper. And the challenge with a lot of CO2 removal approaches is not really considering broader elements than just CDR. And I think biochar is one of those approaches that is very likely to fall in that trap. And I really urge that there be a broader conversation about the many ways in which we can use biochar beyond just trying to monetize the carbon removal value. Knowing again what I mentioned earlier, that any removals that happen between now and when we reach net zero really do need to happen on top of emission reductions. And at the moment, a lot of the companies that are buying these removals, we're not necessarily seeing that happen. There's been some recent studies that suggest that, I can't remember the name of the company now. It's one of these, no, it's not Microsoft. It's another one of these tech companies that have been buying removals. I'll remember the name later. But the point is that from the year where they started buying carbon removal credits, their internal emissions doubled, mostly from travel, right? But they started buying removals and then they doubled their emissions. And that's obviously the opposite of what we're trying to achieve. And here it very much smells like greenwashing. And it is our role to really sort of point that out and suggest that that is not really what we intend by climate action.
Okay, wonderful. Yeah, Matthew.
Sure. So it is clear biochar sits somewhere in between, in terms of the inherent permanence of its storage between geological storage and forestry or ecosystems. And that's what's making it challenging in the EU regulatory context to properly address. That said, I do think, and we see movement in the voluntary carbon market space, for example, with the verified carbon standard, to take the potential of biochar quite serious. And I think that is a good thing in and of itself, with the caveat that Mark outlined in terms of avoiding, of course, that these results are then used to compensate for fossil emissions, at least without, appropriate, let's say, taking into account any possible reversal. I mean, if we manage, if we get greater clarity on what does happen in the fields, for example, and we are able to calculate that into the picture, then I do think, well, biochar does have that potential to contribute more broadly, and it is right now. It is the largest removal aside from forestry activities. So it's not an insignificant, and there are opportunities also commercially to pursue biochar in the voluntary carbon market space.
Yeah, Professor Lin, you want to have feedback?
Yeah, so I would see biochar as one of the ways you use biomass. So Matthew had used an example of Drax project. They basically take the biomass and convert that to fuel. If you simply do that, you can achieve where you capture the CO2 and you're fixing the CO2. But if you can burn the CO2, what they do is they burn the CO2, generate electricity, and capture CO2, store underground. So the whole process is equivalent to getting the CO2 from the air and store it underground. But in this way, you can store CO2 while generating electricity. So I think biochar, to me, that's just one way of using the biomass. But there might be some argument that while producing biochar, there could be some methane emitted into the atmosphere. So that could be the concern. So if you can, do the same thing to like what the Drax is doing, you can use biochar as the fuel. That could be one of the methods. So you can make sure all the carbon is actually stored underground because you force it to, and you can get some energy out of it. I think that could be something we can look into as well.
Okay, thank you, Professor Lin. And I would like to thank you all because from the ICT industry, our board members sometimes discuss the solutions. And right now, our criteria is RE100, 100% renewable energy before 2050. And also they promise net zero. RE100, probably we can reach this, but to be net zero is not easy. And everybody talk, other solutions. For example, lots of our big boss from your list, TSMC, we talk about carbon removal, but it's very far away beyond us because they are ICT industry. But from all of you, the introduction about the carbon removal, the progress, I think we should keep in touch. Especially the certification, MRV, we are waiting for you. So a kind of the cooperations or knowledge sharing or investment. So please keep contact with us. Maybe COP29, we should have a further progress. And I think the ICT industry, because they are the supply chain of the global iPhone, we need a solution. So let's keep in touch and the cooperation in the future. Okay, thank you. Bye-bye. Thank you.
Thank you. Have a good day.
Thank you. Thank you.